Hello and welcome back to the third lesson in our sequences and series unit. Today is going to be a little bit of practice and then a little bit of word problems, so applications that involve arithmetic sequence. So you can see how this stuff is used in real life, right? So the first bit is entirely just like a warm-up practice of everything we've been doing for the last couple days. All right, so question 1, 2, 3, and 4. You can work on that. If you want, you can watch me solve it, or you can skip to the next part where we're going to do, some word problems together so you can see what's going on with that. All right, so I'm going to start with the warm-up and go from there, and you can just fast forward a little bit until you figure out, when I start the applications. All right, so number 1 says, write a rule for the nth term of the arithmetic sequence that goes 12, 10, 8, 6, 4, blah, 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 and then figure out a 10. So the first thing I'm going to do is figure out, well, what are these things going down by? They told me it's arithmetic, so it has to have a common difference, and that's going to be -2. And then I know that my first term is 12. So if I use the rule that we learned in the last lesson, which was that an equals a1 plus n minus 1 times d for every arithmetic sequence, so as soon as it said arithmetic sequence, I knew that I could use this rule. Well, then an is going to equal 12 for the first term, plus n minus 1 times -2. And this is my rule, and I can just leave it this way. Don't need to simplify it any more than that. If I want to find a10, I'm just going to let n equal 10. So I'm going to have 12 plus 10 minus 1 times -2. So that's going to be 12 plus -18. And so a10 is going to equal -6. And there you go. All right, next one, it says one term for an arithmetic sequence is a6 equals -16, and the common difference is 9. Write a rule for the nth term, then figure out what a15 is. All right, so what I'm going to do is start off with that term that they gave me and say, hey, if I plug it into the rule that I have written in red right above, so the term will equal -16. I don't know my first term, but I know that n is equal to 6 right now, and I know that the common difference is 9 because they told me that. And I'm going to be able to figure out what a1 is, because in order to write that rule, I need to know what a1 is, and I don't know what that is yet. So this is going to give me -16 equals a1 plus 45, okay, because I'm going to do 5 times 9. I'm going to subtract that over, and I will get that a1 equals -61. So the rule, an, is going to be -61 plus n minus 1 times 9. And again, you can just leave it that way. You do not need to simplify it. To find a15, I'm just going to let n equal 15. I don't want to write -16 there. I wanted -61 plus 15 minus 1 times 9. And remember, you'll have a calculator for this part. So assuming I did my math right, that's going to be 65. All right, you should double check me on that because I'm a little nervous that I messed it up. All right, next one. Write the rule for the nth term of the sequence if we're given 2 random terms that are not connected. So I'm going to set up a system of equations with this. So I'm going to say, hey, when it equals 39, a1 I don't know, but I know that the n value is 6 at that time, and I don't know d. When it equals 79, I still don't know what a1 is, but I know that the n value is 14 this time around. And so if I clean this up a little bit here, all right, so I'm just going to rewrite this. I'm going to have 39 equals a1 plus 5d, and then 79 equals a1 plus 13d. I can subtract using the elimination method, and I'm going to get -40 equals -8d, and so d is going to equal +5. I'm just going to take this value and plug it into one of the 2 equations. It doesn't matter which one, just whichever one your heart desires. So I'll get 39 equals a1 plus 5 times 5, so that's going to be 25. I'm going to subtract that to the other side. So a1 is going to equal 14. And so my rule, an, is going to be 14 plus n minus 1 times 5. And again, do not need to simplify. Alrighty, find the sum. So we need to remember the sum formula. So for an arithmetic series, so an arithmetic sum, it's always n divided by 2 times the first term plus whatever the last term is. All right? So for this one, we need to know what n is, we need to know what a1 is, and we need to know what an is. So n is the top number when we're written in this summation notation, so that's going to be 21. a1, we're going to plug 1 in. So when I plug 1 into this equation, whoops, I scrolled by accident. I'm going to get 1 minus 2 times 1, so I'm pretty sure that that is, in fact, -1. And an, well, that's really asking us a21 because, you know, n is 21 this time around. If I plug that into this formula, I'm going to get -41. So I'm plugging it into the rule that's right here, 1 minus 2k. Now I'm going to plug this into the formula right there to find the actual sum of these first 21 numbers. Okay, so the sum of the first 21 is going to be 21 over 2 times -1 plus -41. All right? And when I plug this into my fancy calculator, I'll get that the sum is going to be -441. And again, when it's this type, you could check in the calculator and make sure you did it right. Right, similarly, but different, over here, I need to figure out what these guys are. My first term is 60 and my last term is -3, but I have no idea how many terms there are because I have that ... there. So step one is I need to figure out how many terms there are. And I'm just going to reverse engineer things. I'm going to say, hey, when it equals -31, I know my first term is 60. I don't know what n is because I don't know what term this is, but I can see that we're going down by 3 each time. So my d value is -3. And now I can just backtrack and solve for n. So I'm going to subtract 60. That's going to give me -63. That equals a -3 times n minus 1. Let's divide by -3. So that's going to give me 21 equals n minus 1. And then I add that one over and I get n equals 22. And one thing I should note right here is that if you're doing this and you get n equals a decimal or some sort of fraction, then you've messed up because n can only be positive integers, whole numbers that are positive, okay? So if you get anything for n that's not that, then something terribly wrong has happened and you need to try to fix it. All right, enough of that doom and gloom. Let's find the actual sum now. So I'm going to do S22. That's going to equal 22 over 2. I'm straight up just using the formula that's up there. First term is 60. Last term is -3. Okay, so I just do this in the calculator. That's going to give me 627. So the sum of this little pattern here, 60 plus 57 plus 54 plus ... minus 3, is going to be 627. And there you go. So that was our nice review of everything we've done so far. Let us jump to some word problems. And wow, there are a lot of words in this first one. So, a ceramic tile floor is designed in the shape of a trapezoid that is 20 feet wide at its base and 10 feet wide at its top. All right, so we're 20 feet down here and 10 down here. I don't know if we really need that. The tiles, so, oh wow, each one of these tiles, okay, measures 12 inches by 12 inches. And they are to be placed so that each successive row, so each next row, contains one fewer tile than the preceding row. How many tiles will we need total? All right, so let's think about this. We're going to first try to write this as a pattern. So the first one, all right, if it's 20 feet wide, okay, because it says 20 feet wide at the base, and each tile is 12 by 12, well, then we're going to just need 20 tiles here, and we're ignoring grout lines or things like that. Okay, so that would technically be less tiles because they would be a little bit further away from each other, but we're just going to push them right up next to each other and say they take up exactly 12 inches, which is 1 foot. So it's going to be 20 in the next one, in the first one I mean. Then it says that each row contains one fewer tile. All right, so that means that A2 is going to equal 19 and A3 would equal 18, and then so on until we get to the last row, which we know is going to have 10 because it's 10 feet wide. All right. And so our first process here is going to actually figure out, well, how many rows are there going to be here? Which is basically a really fancy way of saying, what is n? Okay. How many of these things are in this sequence until we get to 10 being our final one? So to find that, I'm going to say, hey, when it equals 10, I know my first term is 20. I don't know what n is, but I know that my common difference is -1. So I can reverse engineer now. So I'm going to first subtract that 20. So I'll get -10 equals a -1 times n minus 1. Divide by -1. So 10 equals n minus 1. And n equals 11. So I'm going to have 11 rows worth of tiles here. Okay? So now we can actually answer the question, how many tiles will be required? Which means I need to find the sum of the first 11 rows. And we know, based on our little formula that we've been working with here, that that's just this. So the sum of the first 11 is going to be 11 over 2. And then our first term was 20 because there were 20 in the first row, and there are 10 in the last row. If we plug that into the calculator, we're going to get that there are 165 tiles that are needed. And so this is like a, maybe not a super realistic real life problem, but like it's a real life problem that you could come across. Maybe you're going to be a flooring person someday. I don't know. Don't ask me. Alrighty. Suppose you just received a job offer with a starting salary of $35,000 per year. Oh, wow. You're going to get to live with your parents for forever on that amount. But we get a guaranteed raise of $1,400 per year. Okay, that's probably not enough to keep up with inflation, but whatevs. How many years will it take before your aggregate, that's a really fancy way to say total, okay, your total salary earned over all of those years is over $1 million. So we're trying to say, like, if you add up each year, when will you have made $1 million? You're obviously not going to have $1 million in your bank account unless you don't touch any of that money each year. But, collectively, how much until you've made that? So let's start off with writing the things we know. We know that our first term is going to be $35,000, okay? And we know our common difference is that we're increasing by 1400. So right this second, we can write our rule for this, which is going to be 35,000 plus n minus 1 times 1400. All right? And I'm just going to clean that up. So I'm going to distribute the 144 and add like terms and just clean this up so it's a little bit easier for us to work with. I would get 1400 n, and then it's going to be plus 68600 when I do that math out. Alrighty. Oh, why do I think I've messed up right now? I did totally mess up. That's my bad. I gotta do the math to figure this out. I actually don't know what it is off the top of my head. I didn't actually write it down. So let's do some math real quick. So we're gonna have 35000, and I am subtracting the 1400 from that. All right, that's my bad. Oh, I definitely should have been able to do that in my head. That's probably embarrassing. Don't tell anyone. Yeah. Don't tell. I literally forgot what the number is already. 33600. Was that right? Embarrassing. I know. All right. So I just cleaned that up so that it's a little bit easier to work with. So what I'm going to do is say, hey, I know that the sum is n over 2 times the first plus the last. And I multiply that by n over 2. But we don't know what n is. That's what we're trying to figure out here. All right, is how many years it's going to take for this to happen. And in this case, our term number, like A1 is saying the first year, A2 is the second year, so on. So what I want to know is, when will my sum be $1 million? But I don't know what n is. I do know what A1 is. That was my starting salary, 35000. And then here's where we get this trick going on here, which is that I don't know what an is because I don't know what n is. But I have this little formula that I just came up with for what an equals, which is going to be 1400n plus 33600. And so I can plug that in for an in the equation. And so now when I clean this up, I'm going to multiply the 2 to the other side to get rid of the fraction. So now I have that 2 million equals n times, and here's where I got that original number from. I cleaned this inside up. So 1400n plus 68600. And if I distribute the n through and move the 2 million over, I'm going to get 0 equals 1400n squared plus 68600n minus 2 million. Woo! All right. And let's just clean that up a little bit. All of them can be divided by 1,000, and I'm going to get 14n squared. They could probably get simplified more, but that's just the obvious thing that I saw. And that's going to be 20,000. All right. At this point, what I'm going to do is use the quadratic formula. Now, if you have this programmed into your calculator, then use it. All right. So I'm going to use the quadratic, I don't know why I put an arrow there, quadratic formula. And when I do that, all right, I'm going to get n equals 20.54 and I get n equals negative 69.54. Now, we know n can't be negative, because remember, n is positive integer whole numbers, all right? And we get this 20.54. So I can write in words, it's going to be after 20 years is one way of saying this. Because in the 20th year, it's not going to be there yet, because I have to get to n equals 20.54 in order to get this exactly a million. And so what's actually happening is in the 21st year, this person will have made $1 million over the course of their career here. All right, and that would be my answer here. So I would accept either one, either saying after 20 years or saying in the 21st year that this person would have made $1 million. Alrighty, you should pause the video and you should try the Your Turn yourself. It's got a deck of cards here. My suggestion is that you always try to write what the pattern is, like, write out the numbers to see what's going on. So that's what we did up here when I did 20, 19, 18. So then you can write your rule and go from there. Alrighty, so pause the video. I will be here when you're ready for me. All right, you're making a house of cards. The top row has 3 cards. All right, so I'm going to write 3. The next one has 6. Ooh, the next one has 9, and so on. All subsequent rows follow this pattern. All right, we want to write a rule for the number of cards in the nth row. So that's just our normal writing a rule. We could do that. That's easy. So an equals our first term plus n minus 1, and then we're adding 3 each time. So I'm going to do times 3. So there's my write a rule for the number of cards. Then it wants us to determine the number of cards that would be in a card house that had 11 rows. All right, so I'm just going to have to do a little bit of math here. So A1 is 3 when n equals 11. I mean, that has nothing to do with things. A1 is always 3. My bad. I kind of did this in a really weird way of writing that, but whatever. N equals 11. I need to figure out what the last term is, because I'm going to use the sum formula where I need to know what n is, 11. I need to know A1 is 3. I need to know what AN is, the last term, which is going to be A11. If I plug this into the formula, I'm going to get 3 plus 11 minus 1 times 3. Okay, and the last time I did that math out, that was 33. So now that I have that, I can find the sum of the first 11 rows, okay, and that's going to be 11 over 2 times 3 plus 33. And again, I'm just using the arithmetic series, so the arithmetic sum formula. And when I do that, I'm going to get that this needs 198 cards. And if we felt like being nerds, we could do 198 divided by 52, which is how many come in a standard deck. 54 if you count the jokers. And we can figure out how many decks of cards we would need to buy in order to make this happen. And there you have it. The rest of this stuff is practice. You can, take a look at it, see how you're feeling, and check the answer key out, and go from there. All right, hope you found this helpful. Don't forget to like and subscribe, and I'll see you in the next one.